And this is section 7.7, the final section that's going to be on this Friday's test. And actually, this is the last section we're covering for the midterm exam next week. So this is the last section that we're actually learning. The midterms next Friday. So this section is called geometric sequences, but in order to understand it, we need to understand arithmetic. And this is from semester 1. We did arithmetic last semester. So it says right here on the notes on the board, arithmetic sequences have a common difference d. Okay, so we need to understand what that means. Common difference d. Now, if you're wondering, how do I find the common difference? To find d, you pick a value and then subtract the previous number from it. Now, I underline previous because this is the way we need to do it. Even though you guys might be able to see, oh, from 3 to 5, it's increasing by 2. From 1 to 3, it's increasing by 2. Even though you're able to see that, I would like you to calculate the common difference by picking a number and subtracting the number previous from it. So if I take negative 1 and subtract negative 3, there it is, negative 1 minus a negative 3. This changes the plus plus, so you really have negative 1 plus 3, which is 2. And it's called a common difference because that difference is between every single term. So if I take 3 and subtract 1, that's also 2. If I take 1 minus negative 1, that's also the common difference, 2. Or if I take 5, take away 3, take a number, subtract the previous number from it, that's also 2. So the common difference, it's called common because it's in every single term. If you take a number, subtract the previous one from it, it'll give you the common difference. In this case, the common difference 2. Okay, that's arithmetic. We should be comfortable with that. We already did that last semester. Now, geometric sequences, they have a common ratio, r. They don't have a common difference, they have a common ratio. Now, what do I mean by that? How do you find the common ratio r? To find r, you pick a value and then divide it by the previous number. Okay, so to find the common difference, you pick a value and subtract the previous number from it. Right here, you pick a number and you divide it by the previous number. So I take the number 2 and I divide it by negative 1. And 2 divided by negative 1, 2 divided by negative 1, the answer is negative 2. And that's your common ratio. Now it's called common because it exists between any terms, right? So if I pick 1/2 and divide it by negative 1/4, let me show my work right here. 1/2 divided by negative 1/4. We should all know that when you divide by a fraction, you change the division to multiplication, but you take that fraction and you flip it. So dividing by a fraction is the same thing as multiplying by the reciprocal. So there's definitely a lot more work on this one. 1 times negative 4 is negative 4, 2 times 1 is 2, and negative 4 divided by 2 is negative 2. So you see that the ratio negative 2, it is common. Okay, it doesn't matter which numbers you pick. You could say negative 4 divided by positive 2, that's also the common ratio negative 2. Or if you take negative 1 divided by positive 1/2, that will be the common ratio negative 2. Okay, so the first task or the first skill that we need to be able to do today is to, as you see right there on the learning target, it says we need to be able to identify arithmetic and geometric sequences. So I'm just going to give you some lists, a couple of lists of numbers, and I want to ask you, is it geometric or is it arithmetic? So we have a list of numbers here. Please copy these down in your notebooks. And let's take a look at this first list of numbers. I have 7, 13, 19, 25. Okay, so it looks like it's growing, but we want to find out if there's a common difference or a common ratio. So what do you guys want to try first? Common difference or common ratio? Difference. So how would we do a common difference? Once again, just like it says on our notes, we take a number like 13 and we subtract the previous number from it. So I'm going to write 13 take away 7. And what's 13 take away 7? 6. Okay? So right now I'm thinking that the common difference is 6. I'm thinking that this is my answer, D is 6. But I need to make sure that it exists in all the terms. So if I check this next one, 19 take away 13. Is 19 take away 13 6? Yes. How about 25 take away 19? Is that 6? Yes. So there's definitely a common difference. So what is this, an arithmetic sequence or a geometric sequence? Arithmetic, right? So arithmetic. We have to know whether it's arithmetic or geometric, okay? And how do we know that? We know that by understanding that arithmetic has a common difference and geometric has a common ratio, okay? So arithmetic has a common d. So in this case, the d was 6. That's how I know that it's arithmetic. Now let's look at this next one down here. Negative 96, negative 48, negative 24, negative 12. Now, some of us might be able to see how it's actually decaying, if you will, right? But is there going to be a common difference or a common ratio right here? Now, if you say difference, you could try it. You could say negative 48, take away a negative 96. That's going to be positive. It's going to be a pretty huge number. But then if you go negative 12, take away negative 24, that becomes 12. So it's not a common difference. So we're going to check and see if it's a common ratio. How do we do common ratio? We pick a number and divide it by the previous number, okay? So that's probably not the best two numbers to pick, but we're going to check all of them anyway. So I'm going to take negative 48 and divide it by negative 96. So what do I get when I go negative 48 divided by negative 96? It's not a nice number. It's still going to be a fraction. What is that fraction? Anybody? 1/2. Perfect. So it looks like our common difference is 1/2. It looks like our common ratio. So it looks like our common ratio is 1/2. So R equals 1/2. But I need to make sure that it is common in all the terms. So if I were to pick negative 12 and divide it by negative 24, do I also get 1/2? Yeah. Yes. If I were to pick negative 24 and divide it by negative 48, do I also get 1/2? Yes. So this one definitely has a common ratio of 1/2, which means that this sequence is not arithmetic, it's what? Geometric. So that is the very first skill that we need to be able to do to determine whether it's arithmetic or geometric, or it might be neither, right? Maybe you don't have a common ratio, maybe you don't have a common difference, maybe it's just a random list of numbers, which could happen. Okay?
If it's just random.
So if I did give you a random list of numbers and there is no common difference or no common ratio, you would just say neither. Okay? Let's take it a step further. Let's go back to our notes on the board. So we already know how to determine if it's arithmetic or if it's geometric. It's arithmetic if there's a common difference. It's geometric if there's a common ratio. But we need to take it a step further, and we need to know these notes right here. These notes will produce the function that actually produces the list. Okay? Now, we've done arithmetic in the past. A sub 1 is your first term on your sequence. N minus 1 is n minus 1, and d is the common difference d. So if you were to plug in your first number of your list and your common difference, this function will actually produce the list that you have on your sequence. But today we're focusing in on geometric, so I'm not even going to bother doing this one. I want to focus in on geometric. So the geometric rule, we have to memorize this. A sub n equals a sub 1 times r to the n minus 1 power. A sub 1 times r to the n minus 1 power. Where a sub 1 is your first term, r is your common ratio, and the power n minus 1 is exactly that, the power n minus 1. So what I want to do is go back to the problems that we just did, and I want to focus in on this. Let me get rid of this stuff. So this was the geometric sequence that we had. We said that the common ratio was 1/2, correct? And that makes total sense because from here to here, you multiply it by half, you get negative 48. Multiply it by half, you get negative 24. Multiply it by half, you get negative 12. So the common ratio makes total sense. Now this list of numbers, it came from a certain function. So with the a sub nth rule, let me write down the a sub nth rule. A sub n, and like I said, we have to have this memorized, A sub n equals A sub 1, your first term, times r, your common ratio, to the n minus 1 power. This is what we have to have memorized. So I'm going to use this rule to create the function that actually produces the list negative 96, negative 48, negative 24, negative 12. Check this out. A sub n is just the name of the machine that's going to produce the list. A sub 1, what's A sub 1, guys? Negative 96, that's right, I just circled it. Right, A sub 1 is negative 96, that's your first term on your list. So I'm going to write down negative 96, that's my first term on the list. And then it says times r, so I'm going to put times, and I'm going to put this in parentheses. And what is r? 1/2, so I put 1/2 in the parentheses. Now on the outside of the parentheses, I need to put the power n minus 1, n minus 1. Does that make sense? Power n minus 1, power n minus 1. Now believe it or not, ladies and gentlemen, this is the machine that produces the first term, the second term, the third term, the fourth term. This is the machine that produces that list. Let me prove to you how this rule right here actually produces the above list, negative 96, negative 48, negative 24, negative 12. Okay, so let's say I wanted my A sub 1 term. Let's say I wanted this first term, A sub 1. See, A sub n, that's just a notation for which number you want to find. Okay, so A sub n, if I say A sub 1, that means I want to find my first number. And that would be negative 96, right? So if I did plug in a 1 for the n, that would be 1 take away 1, which is 0. And then 1/2 to the 0 power, that's 1. And then 1 times negative 96, that's negative 96. So A sub 1 is really negative 96, but we already knew that, right? Let me prove to you that this rule, if I plug in a 2 right here, it'll give us our second number, negative 48. So check it out. If I plugged in a 2, now remember this is notation. A sub n, I could write A sub 2. All that is saying is that I'm going to plug in 2 into the n position. So here it is, negative 96 times 1/2 to the, instead of n minus 1, it's going to be 2 minus 1 power. And when I do this math, it will give us the second number, negative 48. Check it out. What is 1/2? What is 2 minus 1? And what's 1/2 to the 1 power? And what is 1/2 of negative 96? It's negative 48. You see how when I plug in 2, it actually gives me my second number on the list? If I were to plug in a 3 instead of n, if I were to plug in a 3, it's going to give me a negative 24. If I plug in a 4, it'll give me a negative 12. Okay? If I plug in a 5, it'll give me the next number down, which is actually negative 6. Right? So, for example, this rule comes in handy when I ask you for something extreme. Like if I told you, what is the 5th number on this list? Is that extreme? What's the 5th number on this list? Here's first, second, third, fourth. What's the 5th number? Negative 6. You didn't do any complicated math. You just know that the ratio is 1/2, so you're dividing by 2, dividing by 2, dividing by 2. So your 5th number is 1/2. And that's easy. You don't have to do anything. You do it with your mind. But if I were to say, find the 17th number, then you would use this, plug in 17 right here, and do all that math, and it'll give you the 17th number on this list. Okay? So let me jump to our homework. So I'm not going to do all the questions on this homework. The video is already long enough as it is. I just want to go through and show you each section. So let's start with what I recently finished using the A sub nth rule, which is the most challenging part of this whole section, using the A sub nth rule. So let's all zoom in on focusing on number 13. Number 13, it says write an equation for the nth term of the geometric sequence 3, negative 24, 192. Okay, so they're telling you it's geometric. So by us knowing it's geometric, we know that there's a common ratio. So let's find that common ratio by taking any number and dividing it by the previous number. So ladies and gentlemen, what is the common ratio here? Take a number divided by the previous number. What's the common ratio? Take a number divided by the previous number. Help me out here. Come on, guys. What is negative 24 divided by 3? Negative 8, right? So the common ratio is negative 8. Are you with me? Okay. So that's the first thing that we need to identify. Now let's recall what the a sub nth rule is for geometric sequences, and it's up on the wall. It's a sub n equals a sub 1 times r, I'm going to put it in parentheses, to the n minus 1 power. Okay? On the board I didn't have it in parentheses. I'm going to put it in parentheses right here. Now, what is a sub 1? You guys remember what a sub 1 is? What does that mean? It's on the notes on the wall. A sub 1 is what? The first number. So a sub 1 is 3. Okay, so let me start writing this rule. They want the rule, they want the function, I'm writing the function. A sub n equals the first number, which is 3, and then times the common ratio. What is the common ratio? Negative 8. And then it's to the power of n minus 1, and I actually leave that to the power of n minus 1. Are you with me? Okay, and that's it. This is the rule. This is the machine that produces this list. If I were to plug in a 1 right there, I'll get a 3. If I were to plug in a 2 right here, I'll get negative 24. If I were to plug in a 3 right there, it'll give me 192 positive. Pretty interesting, right? That rule? Now, check out what the question asks on top of the equation for the nth term. That's the a sub nth equation, but they're asking a second part which says, find the 9th term of this sequence. Again, find the 9th term of this sequence. So, how does this rule work? This rule, if I plug in a 1, it'll give me my first number. If I plug in a 2, it'll give me my second number. If I plug in a 3, it'll give me my third number. Which number do they want? The 9th. So here's the notation. A sub 9, that's really has nothing to do with any math. That's just the name. That's the notation saying that you're going to plug in a 9 in place of n. Okay? So this is just like a notation, some notes. It's saying I'm going to take a sub n and I'm going to plug in a 9 in place of n. So let me rewrite my rule. 3 times negative 8, but instead of n, I'm going to put that 9 right there and then minus 1. Are you with me? So the 9th number is really going to be calculated by doing this. 3 times negative 8 to the 8th power. So on a calculator, do negative 8 in parentheses to the 8th power and then multiply it by 3. Or you could jot it all down exactly the way it is on a calculator. 3 times, open parenthesis, the negative sign, 8, close parenthesis, caret button to be an exponent, put the 8 right there, hit equal, and it's going to be a huge, huge number. The answer, the 9th term on this list, is 50,331,648. And if you flip the paper over, your answers are right there. Could somebody please verify that number 13 is actually that number, 50,331,648? Yes? Perfect. So in these 15-20 minutes of this video, we've explained everything that there is to know of how to identify. Like up here on the first part of the homework, it's identify, right? This first one, there's a common difference right there, so that's arithmetic. If there were a common ratio, it'd be geometric. That's all you have to do on the first part. This next one's easy. Once you find the common ratio of 1 divided by 500, that's 1/5, you'll be able to calculate the next numbers by simply multiplying by that common ratio 1/5. Okay? Or you could just look at the patterns, dividing by 5, dividing by 5, dividing by 5. So this next number will be 20 because 100 divided by 5 is 20. Then the next number will be 4 because 20 divided by 5 is 4. And then the next number will be 4/5 because 4 divided by 5 is 4/5. So on this next part, it's just finding the next 3 terms. The most important part is this complicated part where I give you some numbers, I tell you to find the a sub nth rule using the notes that we have, and then I ask you to calculate the 9th term by plugging in 9 and working it out. That's the best, the most important part. The answers are in the back. I'll make a second video explaining more of these answers.